Right now, as I'm speaking to you, something absolutely terrifying is happening off the East Coast that most people have never heard of, and it is about to unleash catastrophic conditions on millions of Americans who are still reeling from Winter Storm Fern. It's called Bombogenesis, and if you don't know what that means, you're about to get a crash course in one of nature's most explosive phenomena. And I do mean explosive. Let me start with the shocking reality of what's unfolding. Meteorologists are tracking a storm system that is about to undergo rapid intensification so dramatic that its central pressure will drop from 0.008 millibars to potentially 970 millibars in just 24 hours. That's a pressure drop of 38 millibars in a single day, which far exceeds the scientific threshold for what we call a bomb cyclone. To put that in perspective, that's like watching a relatively normal storm suddenly transform into a meteorological monster with the intensity of a Category 2 hurricane, except this is happening in winter over land affecting areas where 115 people have already died from the previous storm. So what exactly is bombogenesis? The term sounds like something out of a science fiction movie, but it's a very real meteorological process that was first formally defined by two scientists, Frederick Sanders and John Gaiakim, back in 1980. The word itself is a combination of bomb, which should immediately tell you this is serious, and cyclogenesis, which is the scientific term for how storms form and develop. When meteorologists use the word bomb to describe weather, you know it's not good news. Here's the technical definition that every meteorologist learns. Bombogenesis occurs when an extratropical cyclone, that's a storm system outside the tropics, experiences a pressure drop of at least 24 millibars in 24 hours, adjusted for latitude. But this weekend's storm is going to blow right past that threshold. We're looking at a pressure drop that could reach 35 to 40 millibars in a single day, which puts this system in the category of what we call explosive cyclogenesis. Now, you might be wondering why pressure matters so much. Think of atmospheric pressure as nature's throttle for storm intensity. The lower the pressure gets, the more powerful the storm becomes. And when pressure drops rapidly, it creates what we call a tight pressure gradient. Essentially, it's like creating a steep hill for the atmosphere to roll down. Air rushes toward that low-pressure area with tremendous force, and as it does, it starts spinning faster and faster due to the Coriolis effect from Earth's rotation. The physics behind bombogenesis is actually fascinating and terrifying at the same time. What happens is you get this perfect storm of ingredients, literally. You need a strong temperature contrast between air masses. You need the jet stream to be positioned just right to provide what we call divergence aloft, and you need moisture. This weekend, we have all three ingredients in spades. The temperature contrast is extreme right now. We've got Arctic air that's been locked in place for over a week, with temperatures still well below freezing across the eastern United States. Meanwhile, the Gulf of Mexico and the Atlantic Ocean are providing warm, moisture-rich air. When these two air masses collide, and I mean really collide with force, it creates the instability that fuels explosive storm development. The jet stream positioning is textbook perfect for bombogenesis. Right now, the jet stream has this amplified wave pattern that is creating what meteorologists call positive vorticity advection at about 18,000 feet up in the atmosphere. Think of it like having a giant atmospheric mixer that's stirring the air with incredible force. This upper-level divergence acts like a vacuum, literally sucking air up from the surface and allowing the surface pressure to drop rapidly. But here's what makes this particular bombogenesis event so incredibly dangerous. It's happening to communities that are already devastated. We're talking about the same geographic regions where 115 people have died from Winter Storm Fern, where 86,000 people in Nashville alone are still without power, where emergency shelters are still at capacity, and where the electrical infrastructure is hanging together by a thread. When a bomb cyclone hits an area that's already compromised, the impacts don't just add up, they multiply. Those ice-weakened trees that are barely hanging on, hurricane-force winds are going to bring them down. Those power lines that crews just finished repairing, they're about to get knocked out again. Those emergency response teams that have been working 16-hour shifts for over a week, they're about to face their biggest challenge yet. The wind speeds we're forecasting with this bomb cyclone are genuinely frightening. Along the coast, we're expecting sustained winds of 50 to 70 miles per hour with gusts that could exceed 80 millisievert. That puts us in Category 1 hurricane territory, but unlike a hurricane, this is happening in winter when trees are more brittle, when roads are already hazardous, and when people's tolerance for extreme conditions is already stretched to the breaking point. Let me walk you through what happens during bombogenesis, because understanding the process could literally save your life if you're in the path of this storm. The process occurs in three distinct phases. The first is the incipient cyclone stage, where the initial low-pressure area forms along a temperature boundary. During this stage, pressure might drop slowly, maybe 2 to 3 millibars per hour, which is normal for developing winter storms. Then comes the rapid deepening stage, and this is where the bomb cyclone gets its name. During this phase, which typically lasts 12 to 18 hours, the pressure drop accelerates dramatically. We're talking about pressure drops of 1 to 2 millibars per hour during peak intensification. It's during this phase that winds increase rapidly, precipitation becomes heavy, and conditions deteriorate from manageable to dangerous in just a few hours. The final phase is the mature cyclone stage, where the storm reaches maximum intensity. Even though it's not getting stronger anymore, this is when it's most dangerous because the winds are strongest, precipitation is heaviest, and storm surge is highest along the coast. For this weekend's event, meteorologists expect the rapid deepening stage to begin Friday evening and continue through Saturday afternoon. This timing is particularly concerning because it means the worst conditions will hit during the weekend when emergency services may be operating with reduced staffing. The snowfall rates we're forecasting during peak intensity are genuinely unprecedented for this region. During bomb cyclones, snowfall rates can exceed 4 inches per hour for extended periods. We're looking at 12 to 18 inches from the North Carolina coast through southern Virginia, with some isolated areas potentially seeing over 2 feet. But it's not just the total accumulation that's concerning. It's the rate at which it's going to fall. When snow falls at 3-4 inches per hour for extended periods, it becomes impossible for road crews to keep up. Visibility drops to near zero. Travel becomes physically impossible. Emergency vehicles can't respond to calls. People who need to evacuate or seek shelter become trapped in their homes. The coastal impacts are going to be severe as well. When a bomb cyclone develops just offshore, it creates massive waves and storm surge. We're approaching a new moon phase, which means spring tides, the highest tides of the month. When you combine spring tides with storm surge from hurricane-force winds, you get the perfect recipe for catastrophic coastal flooding. The historical context for this type of event is sobering. Some of the most destructive winter storms in East Coast history have been bomb cyclones. The storm of the century in March 1993 was a bomb cyclone that killed over 300 people and caused more than $5 billion in damage. The February 1978 blizzard in New England killed over 100 people, many trapped in their cars by rapidly accumulating snow and hurricane-force winds. What makes this weekend's event particularly frightening is the compound nature of the disaster. The communities that are about to get hit are already dealing with the aftermath of Winter Storm Fern. Emergency services are stretched thin. Power grids are compromised. Supply chains are disrupted. People are exhausted, both physically and emotionally, from dealing with the previous storm. The psychological impact of back-to-back extreme weather events cannot be understated. When people are just starting to recover from one disaster and then get hit by another that's potentially worse, it can break communities in ways that go beyond physical damage. We're talking about long-term mental health impacts and social disruption that can last for years. From a scientific standpoint, bomb cyclones represent the atmosphere at its most dynamic. The amount of energy involved in rapidly dropping a storm's pressure by 30-plus millibars is almost incomprehensible. We're talking about the equivalent of millions of tons of air being displaced in hours. The visual aspects of bombogenesis are as dramatic as the meteorological data. Satellite imagery shows these massive spiral formations that look almost identical to hurricanes, except they're happening over much colder waters and affecting much larger geographic areas. The eye wall-like structure can span hundreds of miles, creating multiple bands of heavy precipitation that rotate around the storm center like a gigantic atmospheric buzzsaw. The forecasting challenges are enormous. While we can predict bombogenesis will occur with high confidence, the exact details of intensity, track, and duration can vary significantly, even 24 hours before the event. That's why meteorologists have been updating forecasts multiple times daily. Small changes in initial conditions can lead to dramatically different outcomes. What's remarkable about this weekend's event is that all three major forecasting models, the global forecast system, the European model, and the Canadian model, are showing similar solutions. That's unusual for bomb cyclone forecasting and gives meteorologists higher confidence in the overall scenario. The three primary threats from this weekend's storm are heavy snow leading to structural damage and transportation paralysis, hurricane-force winds causing widespread power outages and tree damage, and coastal flooding from storm surge combined with astronomical high tides. Hurricane-force winds over land behave differently than hurricane winds over water. When you have 70-plus mph winds hitting areas with trees already weakened by ice damage from Winter Storm Fern, you get what emergency managers call catastrophic tree failure. This isn't just a few trees coming down, this is hundreds or thousands of trees falling simultaneously across entire regions. The power grid implications are enormous. Utility companies that have been working around the clock to restore power from Winter Storm Fern are about to face potentially even more widespread outages. Some areas could lose power again before they even get it back from the first storm. The cumulative impact on electrical infrastructure could take weeks or months to fully repair. Emergency management officials are particularly concerned about what they call cascade failures, situations where the failure of one system leads to the failure of multiple other systems. If widespread power outages disable cellular towers, emergency communications become compromised. If roads become impassable due to snow and fallen trees, emergency responders can't reach people who need help. The economic implications are staggering. Insurance industry analysts estimate that Winter Storm Fern caused over $8 billion in insured losses, and that number is still climbing. A second major storm hitting the same areas could easily add another $3 to $5 billion in losses, creating what the industry calls loss amplification, where back-to-back events cause disproportionately higher damage. Supply chain disruptions from this compound disaster scenario could last for months. Many distribution centers and logistics hubs damaged during Winter Storm Fern are still operating at reduced capacity. Port facilities along the eastern seaboard are still dealing with backlogs from the previous storm. If this bomb cyclone shuts down transportation networks again, it could create cascading delays affecting everything from medical supplies to food distribution across the entire eastern United States. What's particularly concerning from a climate science perspective is that bomb cyclones appear to be becoming more frequent and more intense in recent decades. Research published in the Journal of Climate shows that bomb cyclones in the North Atlantic have increased in frequency by about 4% per decade since 1979, with the most significant increases occurring during winter months. Warmer ocean temperatures are providing more energy for rapid intensification, while changes in the jet stream are creating more favorable upper-level patterns for explosive cyclogenesis. The mathematical equations meteorologists use to predict bombogenesis are incredibly complex. The Sutcliffe development equation helps forecasters understand how quickly a storm will intensify, taking into account factors like temperature advection, vorticity advection, and diabatic heating rates. But even with these sophisticated tools, there's still uncertainty because small changes in initial conditions can lead to dramatically different outcomes. What makes the science of bombogenesis even more fascinating is the role that diabatic heating plays in the process. When water vapor condenses into precipitation during the storm, it releases latent heat energy into the atmosphere. During a bomb cyclone, this process happens so rapidly and on such a large scale that it actually helps fuel the storm's own intensification. It's like the storm develops its own internal engine that keeps making it stronger and stronger. From a meteorological research standpoint, this weekend's bomb cyclone is providing scientists with a rare opportunity to study rapid intensification processes in real time. The National Weather Service has deployed additional radiosondes weather balloons that measure atmospheric conditions at various altitudes to gather more data about the storm's structure as it intensifies. NOAA's Hurricane Hunter aircraft, typically used to study tropical cyclones, are also being deployed to fly through the bomb cyclone to measure wind speeds, pressure, and temperature. The international meteorological community is paying close attention because bomb cyclones are not unique to North America. Similar rapid intensification events occur in the North Atlantic, affecting the United Kingdom and Western Europe, and in the North Pacific, affecting Japan and the Western United States. For people in the path of this bomb cyclone, preparation is absolutely critical, and time is running out fast. This is not a storm you want to be caught unprepared for. If you lose power during a bomb cyclone, you could be without electricity for days or weeks, especially if you're in an area already damaged by Winter Storm Fern. The bottom line is this: bombogenesis is one of nature's most powerful phenomena, and it's about to unleash its fury on communities already struggling to recover from a previous disaster. The combination of hurricane-force winds, heavy snow, and existing infrastructure damage creates a scenario emergency management officials are describing as potentially catastrophic. This is not just another winter storm. This is an explosive meteorological event that represents the atmosphere at its most dynamic and destructive, and it's targeting some of the most vulnerable communities in the country at their most vulnerable moment. Understanding the science behind bombogenesis helps us appreciate just how extraordinary this weather phenomenon is. But it also helps us understand why meteorologists are so concerned about what's going to happen this weekend.